All righty, folks. How we all doing here? Good to see you all today. Let's see here. How we all doing? Good to see you all today. So to begin with, we're going to be talking about our last type of conic section. This is called a hyperbola. Now, hyperbolas, they're going to have a center. Again, it doesn't have to be at 0, 0 like it is here on this one. But they're going to have some center, and we're going to call that H and K again. And the center is going to be located in between the vertices. So that vertices is still going to be going out one direction. Might be horizontal, might be vertical. But it's always going to be that A value that gets us out to the vertices, just like it was on the ellipse. It's always the A value. But if you notice, this time, the focus is on the outside. So it's like taking an ellipse, cutting it in half, and then turning it the opposite way. So the foci this time will be on the outside. So they're not inside anymore, they're on the outside. That'll be our C value going all the way to the outside. So this time, instead of A squared minus B squared equals C squared, it's going to actually be A squared plus B squared equals C squared. Now, we don't actually have a co-vertice or any of that other kind of stuff. The B value is literally just going to tell you how wide to make it, how wide to make your graph. So the B value is going to really be nothing more than just figuring out how far to make this imaginary value going out. Because again, we've already seen how there's horizontal and vertical ellipses on the algebraic form of a hyperbola. Well, we have them on this one too, but they're more diagonal ellipses. So the B value is essentially going to do nothing more than allow us to figure out the slope to an ellipse. So on the horizontal ellipse, the slope is B over A for this one, and it would be negative B over A for the other one. Now, we could also have a vertical ellipse, and you'll see that as well. It says, or vertical hyperbola, and you'll see that as well. And you'll see this word transverse, and we'll talk about that here in a second. All right, it's just a fancy schmancy word. It doesn't do a whole heck of a lot for you. So here we go. You got your vertices, you got your foci. You got the B value. This time it would be going out left and right. So we have our B value going out left and right. So B there, B there. And what you notice, you see this box, we just use that box to, however far out we go from A or from B, we just use it to create a rectangle through the vertices, because it helps us determine the asymptotes, what the asymptotes are actually going to look like as we go out from our center, and we know how to make wide then to make our hyperbolas. So the only difference here on the vertical one, all the stuff goes on the outside, but the slope, instead of B over A, this time it's going to be, it'll be A over B, since the A is always the longer always the direction we're going here. So this would be plus or minus A, oops, positive A over B. And this asymptote would have a slope of negative A over B. And again, our hyperbola is just going to go from the vertices out to the asymptotes. You can just make a rough sketch of it. That was ugly. Doesn't have to be exact. But the other thing you're going to see is this word transverse. So the transverse axis, it's just a fancy schmancy word. It doesn't do us a whole heck of a lot of good. It's just a word that just means what's the distance between our vertices. So that transverse axis is equal to 2a. It's the distance between our vertices. Other than that, it's not going to do a whole heck of a lot for us. We're just going to play with this idea of hyperbolas today. So, and then afterwards, we've got one extra little thing we'll do after that. So first up, let's go ahead and clear all this off. Whoop. And we are going to go to a different screen. All right. So let me give you one. Let's just have you guys try to use that information we just came up with. Let's see if you guys can go through and figure out what would be. Oh, apparently, I'm still on the fat line. I am. There we are. What would be the various pieces of the actual hyperbola that we have right here? Now, notice I didn't necessarily spend a whole lot of time. You guys have those formulas back on the other page. We didn't really, you didn't need me to go to you this time because, again, a lot of this is just going to be counting. Okay, well, why don't you guys see what you guys can do? Go ahead and try to see how you can graph this. I'm going to go ahead and just write some random information over here. So while you guys are doing that, I'm just going to be throwing up some random information here on the horizontal and vertical hyperbolas. All righty, friends, let's go ahead and see where you're at and see if we can give it a try. Oh, I guess I probably should make an axis real quick here. Whoop. Whoop. I should probably move that up a little bit. There we go. That'll work. All right, so the center, that's always going to come first. And let's see here. I'm going to have a vertices here. Foci. You guys probably didn't do this, but I'm going to go ahead and throw this on there as well. Before we're done here, we'll come up with the equation of our asymptotes. But hopefully you did the center, the vertices, and the foci. So the center for this one, our graph is going to be, just like before, opposite of x, opposite of y. So 3, -4. So 1, 2, 3, down 4. 1, 2, 3, 4. There's our center. Now, the direction, left, right, up, and down, is not based upon what the bigger denominator is. It's based on what variable comes first. So since x comes first, I know that my hyperbola then will be going left and right. I don't know how it's going to go left and right. I know, though, that I'm going left and right. So it has nothing to do with the denominator. It has everything to do with what term comes first. So we're going to get our a value again. So a is 4. So I'm going to go out 4. So 1, 2, 3, there's a vertice there. 1, 2, 3, there's a vertice there. So that means I'm going to be out 3, so -2, -4. That's not 3 away. I should try that again. -1, -4, and 7, -4. So those are my two vertices. My B value is going to be whatever the square root is on the second one. So B is 3. That means I'm going to go up 3, 1, 2, 3. Notice I'm not going to put a point there. I'm just allowing myself to know just how wide my imaginary box is here. So I'm going to go ahead and create now my little box. So when I do go and graph my asymptotes, they will go through the corners of my box. It just helps me figure out how wide. So how wide my graph is going to eventually be. So to do the asymptotes, we're just going to go from our center, and we are going to go up through the diagonals like that. We're just going to go through the diagonals, and it's just going to help me figure out how wide my graph is. We can carry this off the other direction. It's not like anything really special or scientific about it. And again, I'm not exactly staying exactly out the way the slope of it is, but it's fairly close. But if you remember, when I go to write my equations, if you remember back in Algebra 1, we learned the point slope form. Everybody's used to y equals mx plus b, but there was that other one, that y minus y1 equals m times x minus x1. This was called the point slope form. So we're going to use this form. Actually, this is the form of a line we use in calculus the entire time as well. So might as well get used to using this one from here on out. So the y and the x right here, that's going to be our actual y and x from our center, because we know that our asymptotes have to pass through our center. So we're going to go through and we are going to include our center for our x and y. So I had a plus 3, that'll be minus 3. I had a negative 4, that's going to be a plus 4. And the other part we need to do is we need to have the slope. We need to have the slope of our line. So whatever it is, essentially you take, if you want to think of it in terms of not necessarily b and a, just take the square root of the y denominator divided by the square root of the x denominator. That's another way to think of it. So always, the square root under my y denominator is 3, so I'm going to put the 3 there. So 3. And I always have a plus and minus in front of it. And the square root underneath my x denominator, well, that's 16. That's a 4, so I'm going to put a 4 here. So there we go. That's the equations of my asymptote. And I can go through here. I can see that it passes through that center. Then 1, 2, up 3, 1, 2, 3, over 4. So the foci is the only other thing we haven't talked about yet. The foci, instead of subtracting our denominator this time, now we're going to add them. This is going to be a true Pythagorean theorem. So c squared equals a squared plus b squared. So c squared is 25. Take the square root of both sides, and I get c equals 5. So I'm going to go out the same direction as my vertices for my foci. Biggest key to remember here is start at your center. Some of you guys will start here at the foci and you'll count 5 out that way. Start at the center. So 1, 2, 3, 4. So it's not 5 away from my vertex, it's only 1 away, but it's 5 away from my center. 1, 2, 3, 4, and 5. So now we have all that good information here. We can go ahead and we can make our graph. So here we go. There's part of it right there. Here comes the other part, like that. All right. Notice we're not using quite as much information, need quite as much as before, but we do need to have a few things. Oh, I guess I never wrote down what the foci were. I probably should do that real quick. What was that? That was -2, -4. And 8, -4. All right. All right, well, friends, let's have you try one of these on your own here. But just for the fun of it, instead of that doing a normal one, how about I give you guys one where you have to complete the square? We'll do a couple ones that complete the square. All right, because completing the square for a hyperbola sometimes can be a little bit on the rough side. So let's see how you guys do. Here's the equation for you. Oh, it's too black. 9x squared minus 4y squared plus 18x plus 16y minus 43 equals 0. All right, friends. Why don't you guys go ahead and complete the square and see if you guys can just come up with the equation. Don't do anything else, just complete the square. While you're doing it, I'm going to be using my good old buddy magic eraser here. Yes. Big fan of magic eraser. All righty, friends. Let's just see how you did here. Again, just like before, we're going to break up our x's and our y's and move the constant over. But you guys hopefully remembered the thing I've been telling you from the beginning here. It was a positive 18x. We have to make sure that we always put a plus, an addition sign in between our groups. Now, when I factor out my 4 for my y squared, that's when I'll bring the negative out. But don't factor it out too early. All right, so now I'm going to take out my 9. So x squared plus 2x. And this is where I'm going to take out my -4. So that makes it a minus 4y. That is probably one of the first two things that people miss the most, is they make that a positive 4y instead of a minus 4y, because they forget they took out a minus from it. I'll show you the other thing that is also commonly missed here in a second as well. All right, so here we go. We're gonna do our boxes here. And again, you don't have to use boxes. You could have done the middle number divided by 2 squared and been just fine. So we have our x squared. We have a divide 2x in half slash positive 1x, positive 1x. So x plus 1, x plus 1. And the number we're missing there is 1. So we're going to add a 1 here. Now realize, again, it's not just one that's going to the other side. It's 9 times 1. And again, that's a little bit missed, but that's not the second big thing that people miss I was telling you about. Get to that here in about 1 second. Minus 2y. Minus 2y. So we split it in half. So I got a y minus 2. Y minus 2. And that gives me a positive 4. Now here's where people mess up. Even my friends that put 4 times 4 on the other side, here's what they forget. This is where the negative comes into play. It's a negative 4 that I'm bringing over when I multiply it by, not just a positive 4. So I got to bring that all the way with me. So I got to make sure to make that number a negative. So a negative 4 times 4. All right. So we have 9. X plus 1 squared minus 4 y minus 2 squared equals 52. That'd be a 36 there. So friends, we're going to go ahead and we'll divide it by 36. Divide by 36. And divide by 36. And remember what we said about simplifying. Just simplify the number parts. Essentially, you just take the denominator divided by the numerator. Now notice, I'm going to leave my minus out of this when I divide it. So I have x plus 1 squared over 4. That almost made it look like a 4, huh? There we go. Minus y minus 2 squared all over 9 equals 1. All right. So if you made a little mistake there, don't worry about it. Go ahead and pause the video and do the rest of it, and then we'll talk in a second. All right, let's see how you guys did. All right, I see a negative 1. I see a 2. There's my center. X came first, so I'm going left and right. Notice the bigger denominator is under the y, but that doesn't matter here. What matters is whatever number is in front of, or whatever number comes first. Ellipses, the biggest denominator was your a value. On hyperbolas, it's whatever number comes first is your a value. So I'm going left and right still. So I'm going to go left 2, right 2, and then I'm going up 1. My b value was 3, so I'm going to go up 3. Not, again, remember, I'm not making these into dots. They're not points. They're just helping me figure out how wide to make my hyperbola. That's all they do, just how wide. All righty. So I forgot to write the coordinates of my vertices. Probably should do that real quick. I got a negative 3, 2. And I got 1, 2. All righty. Now we're going to go ahead and we're going to take our asymptotes and we're going to go diagonally through every single little thing. Oh, friends, we are in the presence of greatness. Coach McNally is about to become YouTube famous as this video is going on YouTube. All right, Coach McNally, I'm telling you, I am now up to 42 subscribers here with these little math videos. Wow, I'm telling you, big time. All righty, gang. So we're going to keep it going on all the way out here. And as we go, all right, I'm going to mute myself here real quick. I'll be back with you guys in one. Our Wildcats were kind of giving me a shirt to enjoy our football team eventually when they get back out there. So very exciting there. Can't wait to cheer on the boys. All right. Let's see here now. Oh, I just put those under my foci, didn't I? All right, well, let's do this. What happens when I got I'll go there. I'll just write the foci underneath it. So the asymptotes, again, y minus whatever my y value is of my my center was 2, so y minus 2, plus or minus my b over a, so that'd be 3 over 2. And then my x value was a positive 1, so x plus 1. All right. Now we got our foci here, friends. Here we go. We're going to have a squared plus b squared equals c squared. So we're going to just add our denominators this time. 4 plus 9, that'd be 13. And we're going to take the square root of that. All right. So our foci then is, I'm going to have to come down here a little bit now. We're going left and right still, so -1 plus or minus root 13. And then we have our y value 2. So 13, square root of 13, that's halfway between square root of 9, which is 3, and square root of 16, which is 4. So I'm going to go out 3.5 then. 1, 2, 3, it'll be about there somewhere. 1, 2, 3, about 3.5 or so. So that's about 3.5. Again, it's not exact. Don't quote me on it. All right. Don't come in tomorrow in class, Mr. Williams, square root of 13 is not 3.5. I know that. But we're just using that as a way, kind of a guesstimate of where to put those foci. All right, so from there, we're going to go out, and we're going to come down. We're going to go out, and we're going to come down. All righty. Well, this is usually a tougher one, so I'm actually going to give you guys another one of these to do, and this is the one that's actually in your notes. So that wasn't the extra one I wanted to give you. Now, here we go. Let's have you guys try one. 16 y squared minus x squared plus 2x plus 64y plus 47 equals 0. All right. I'm going to go ahead. Why don't you guys go ahead and pause the video here and see what you guys can do with that while I go ahead and erase the board. All righty, here we go. Here we go. Yeah, it's very exciting. I can't wait for this COVID stuff to be done. Can't wait to get the boys out there, watch Coach McNally and the football team take it and go with it. I want to get my soccer team back out there. So Coach McNally is also technically on our staff for our soccer program as well. He's our strength and conditioning coach. Does a phenomenal job. There's a reason why we've had quite a bit of, been fortunate to have a lot of success the last couple of years. So, all right, here we go. We're going to split up our X's and Y's. And let's see here. That would be a positive 64y right there. Remember, we're going to keep all our X's and Y's together. And remember what goes in the middle. We're going to put a plus. So negative x squared plus 2x equals a negative 47. Okay, we're going to factor out our values here. I'm going to shortcut these ones this time. So we talked about what that shortcut might look like. All right, so notice when I take out that -1, that makes this a negative 2x now, not a positive 2x. A negative 47 plus, plus, there we go. All right, so that middle number, we don't have to draw a square. We could just do it this way, plus 4. Take that middle number divided by 2 and square it. That will be 4. So again, we're not just adding 4 to both sides. I got to make sure I remember that 16 on the outside. So 16 times 4. And now I'm going to have to go ahead and get my middle number here. So -2 divided by 2 squared. That's going to be 1. But again, it's not just 1. You guys are probably used to me saying it by now. Make sure you bring that negative with it as well. So -1 times 1. So we have 16. And to figure out what number goes in here, you just take the number inside the parentheses. Take the number inside the parentheses. So +4 divided by 2 is a +2. So I'm going to add in there just then a +2. Squared minus 1 times x squared. And again, what number goes in front of there? Just take the number inside the parentheses here. -2 divided by 2 is going to be a -1. So we're going to put a -1 here. And we're going to make that equal to -47 plus 64 minus 1. That's going to end up being 16. So we're going to divide everything by 16 now. All righty. So we're going to do our division again to simplify our fractions. I don't have to put a 1 underneath this first denominator, but I'll be honest with you, I always do. I want to remember that, hey, that is doing something there. I'm going out 1 minus x minus 1 squared over 16 equals 1. All right. So center. Our opposite of our x, our opposite of our y, so that'd be 1, -2. Let's go graph that. 1, -2. Okay. So our a value this time is not the x, it's the y value. That's all right. So a is 1. That tells me that my hyperbola is going to go up and down. So there's my vertices. Up 1, down 1. So we'll go and write those in there. So what do we got there? We got a little bit of 1, -3. And we got 1, -1. That works. Yep. And we're going to go get our b value now. This time the b is with the x, so b is 4. All right. So, I mean, this is going to be a very flat hyperbola. 1, 2, 3. Again, it's not a point. It's just a line. Just, oopsies. I went too far on that, didn't I? There we go. That's what I wanted. All righty. We'll do our asymptotes here. Notice how they're very, very flat this time. Very flat asymptotes. So again, our y minus y, the y value of our center. So since our center had a -2 y value, it'll be +2 equals plus or minus b over a. Notice the, I'm sorry, not b over a. This time is a over b because it's a vertical one. So 1/4 and x minus 1. So we can go ahead and draw our hyperbola coming out now. It's a very flat hyperbola. And the last thing we need is our foci. So c squared equals a squared plus b squared. So c squared equals 17. So c equals plus or minus root 17. And friends, that's just a little bit over 4. So I'm going to say it's about 4.1. It's probably not quite. It's obviously not exactly 4.1, but it's about that. So when I go to graph this, I'm going to go just a little bit past 4.1. All right, so here we go. Let's go ahead and graph those points. So a little past. So 1, 2, 3, 4, and a little bit past. 1, 2, 1, 2, 3, 4, and just a little bit past. Not too far, just a little bit. All righty, friends. So that's graphing them. I'm going to do, now also we got a few extra little things to cover, which we want to make sure we do here. So let's go ahead and clear this out of the way, and we'll go take a look back at the note page. All right, and we're going to get ourselves back to dealing with graphing these things. And then we'll get on to our very last thing. So we got 2 quick things left. Not a big deal, but that'll actually finish off conic sections, which is our essential skill for this chapter. This chapter is shared with matrices, which nobody can tell you what a matrix is. You have to see it for yourself, but friends, I'm going to tell you what a matrix is. So I guess that's not entirely true. But matrices will not be an essential skill. It's something I'm going to test you on, but you'll only be tested on it once, not twice. All right, so let's graph our vertices here. 6, 3. So 2, 3, 4, 5, 6. 1, 2, 3. All right, I got a vertex here at 6, 3. And I have another one at 2, 3. Okay, so the vertices, once we have those, we can get our center. So the center then is going to be located. Remember what we said, it's always the average. So 6 plus 2. Average of our x's, and then the value that doesn't change stays the same. So 6, that'd be 4, 3. So it's halfway between the vertices, which I guess, honestly, let's not kid ourselves. That makes sense. It's the center, and it has to be halfway between. So that means our a value is 2. Now we got to do our foci. So that's going to be one more, 7, 3, and 1, 3. That's our c value. So that means our c value, that is 3. So if we can figure out what, remember that c squared is a squared plus b squared, I bet we can figure out what our b squared is. And again, we don't need to know what b is itself. We just need to know the b squared for the equation. So 3 squared equals a squared plus b squared. So 9 equals 4 plus b squared. 5 equals b squared. So the next thing we got to figure out, is this a horizontal or is this a vertical one? And if you look at it here, notice it's going left and right. That means it's a horizontal one. That means our x value comes first. So let's throw that up here. So the a always goes underneath the first denominator. Y minus k. And now we can plug in all our numbers, friends. So the x value is 4. Oopsie, I wanted to change colors there. So x minus 4. All over a squared, which is 2 squared, or 4, minus y minus our k value over b squared, which is 5, and that equals 1. All righty. So we can write equations. The last thing we need to just kind of talk briefly about, friends, is what do we do if we don't know what type of equation we're dealing with? So, how do you know which conic section is which? Well, one of the ways to tell is literally, oh, that's not what I wanted. If we go back to the general form of all conic sections, so ax squared plus by squared plus cx plus dy plus, you're probably expecting e, but remember, can't use e, e's a number, plus f equals 0. So the way you can tell what's what literally just comes down to whatever is in front. That's all it is. Whatever is in front. And here's how we know. If it is ax squared, no, let's not write that. Let's do this though. We have our 4. If we have plus, so ax squared plus by squared, and not just plus, if it is where a and b are the same, friends, it's a circle. It's a circle. You can already tell just by looking at it that it's a circle. For an ellipse, again, very close to a circle, but the one difference is a and b are not the same. They're different. Remember what we said at the beginning? A circle is considered a perfect ellipse. That's because a and b are equal. Hyperbola is not too bad. Just look for a subtraction sign. If you have one square subtracting another square, if you have one that's negative, one that's positive, and friends, you have a hyperbola. For a parabola, you only got one square. It's either have an ax squared or you got by squared. You only got one square. But not only one square. The parabola probably should be the easiest one you can tell just by looking at it. So here's what I'm going to do. Last thing. I'm going to give you guys 4 equations, and I'm going to ask that you guys pause the video and see, can you determine which one of these is which? Because we should be able to just look and be able to tell which one is which. So let me write up a couple equations for y'all. So they would be written in general form like this. Probably, as we're going through this, you probably can already tell which one's what. This will be our last thing here. I know this is a little bit longer video than the last couple, but that's because we got to go over this last little bit here. And hyperbolas tend to be a little bit more challenging for friends in general. All righty, x squared plus 3y squared plus 8x plus 2y minus 27 equals 0. All right, why don't you go ahead and pause the video and figure out how to tell which one's which. All right, let's see how you guys did. So first up, I can already tell I got 2 squares, so it can't be a hyperbola. But I have one that is positive, and I see in between here, I see a negative in between them. So if I see two squares and a negative, friends, that means this right here has to be a hyperbola. Hyperbola. All right, let's go to the next one. Always start off, you want to box up your squares. Oops, I don't want to use that color. Use that color. There we are. All right, I only have one thing squared. So friends, if I have one thing squared, what would that be? If I have one thing squared, that would be a parabola. A parabola. All right, we'll keep going here. I got two squares. Okay. I have a plus in between. All right, that means it's a circle or an ellipse. So then I go look at what I'm dealing with here. I have a 3. I have 3. They're the same number. Since I have two things squared and they're the same number, that means this right here, friends, that's a circle. All right, let's keep going here. Last one. What's this one going to be? Ellipse. How do you know? It's the only one we haven't done. True, but let's talk it through. All right, so we have two things that are squared. It's an addition, so that tells me it's either an ellipse or it's going to be a circle. Therefore, I look at the numbers in front of it. I have a 1 in front of the x squared. I have a 3. Oh, the numbers aren't the same. And since they're not the same, that tells me then that this has to be an ellipse. All righty, friends. So, gone through all the conic sections. The next 4 days, we'll be playing around with matrices, and we'll give you time to kind of really work through conic sections as well, a little bit more to really grasp it. But I will see you guys on Monday. All righty, take care.